Here are the answers for the homework. On number 1, it should be 100. It should be 129 miles and 139 million miles, I should say. 129 million miles, 139 million miles. All right, number 3, you had to figure out how many miles that the item was away, and that would be 169,000, 180,000, and so on. You can check the rest on your own. All right, here's 4A. This was about the space station. And you should have answers of 0, 62, 119, 168, 206, 230, and 238. This one you had to give an explanation for on B. And I'll leave it up there so that you can read it, but I'll give you the brief summary. The whole basis of the problem is that when you're going from the center of the Earth to the center of the Sun, you're dealing with 93 million miles. So there is room for error in there. But when you're going from the center of the Earth out to the space station at 238 miles, that's not a whole lot of room for error in comparison to what you have with the distance to the Sun. The objective today is just F-TF.A.2, which is going to be the unit circle, and how you can use that to find various trigonometric items. So we're going to start with a little review here. Find the lengths of the sides of the right triangles below, each of which has a hypotenuse length of 1. Alright, so here's the first one. The hypotenuse is 1. This is a 30, 60, 90 right triangle. 30, 60, 90 right triangles are very special. The side opposite of the 30 degrees is the short leg. Of course, this is the hypotenuse. And the side opposite of the 60 degrees is the long leg. And you should remember from geometry that to go from the hypotenuse to the short leg, you have to divide by 2. So if the hypotenuse is 1, the short leg is going to be 1/2. And to go from the short leg over to the long leg, you have to multiply by the square root of 3. So 1/2 times square root of 3 comes out to just be square root of 3 over 2. The other type of triangle on here is a 45, 45, 90 right triangle. It is a special one too, whereby the legs are equal to each other. And to go from a leg to the hypotenuse, you have to multiply by the square root of 2. If that's the case, then to go from the hypotenuse back to a leg, you would have to divide by the square root of 2. So 1 divided by square root of 2 is the preliminary answer, but you cannot leave it in that form because you have a radical 2 on the bottom. That means you have to simplify it by multiplying the top and the bottom by that radical item from the bottom. And that will give you an amount of square root of 2 over 2. So if that leg is square root of 2 over 2, then this leg is square root of 2 over 2 as well. Here's another 30, 60, 90, except it's drawn differently. And still the short leg is across from the 30 degrees and the long leg is across from the 60. The hypotenuse is across from the right angle. To go from the hypotenuse to the short leg, you have to divide by 2. So again, the short leg is still 1/2. And to go from the short leg to the long leg, you have to multiply by the square root of 3. So once again, we get square root of 3 over 2 for the long leg. Other things that you have to remember from geometry are how to find sine and cosine given certain items on a triangle. And in this one, it wants you to find sine and cosine. Alright, so you have sine theta. If we do sine theta, we know that sine is going to be opposite over hypotenuse. And the opposite here is 5. The hypotenuse is 13. The adjacent is the side that touches the angle, and that would be this one. So from opposite over hypotenuse, you know you should have 5 over 13. And of course, cosine theta is adjacent over hypotenuse. And adjacent is 12, hypotenuse 13. In this section, you could do 5 divided by 13 and come out with something that's a little under a half in terms of a decimal, but that's of no use to us in this section. We're not going to do decimals unless we're solving for the height of a flagpole, which we're not. We're doing the unit circle, so you have to leave them in simplified fraction form and simplified radical form as well. Suppose that point P is the point on the unit circle obtained by rotating the initial ray through 30 degrees. Find sine 30 degrees and cosine 30 degrees. Before we do that, you need to understand what this is here. X squared plus y squared equals 1 is the unit circle. If you were to graph that, it would make a circle with a radius of 1. That comes from the general form of x minus h, quantity squared, plus y minus k, quantity squared, equals r squared, where hk is the center and r is the radius. So notice in this x squared plus y squared equals 1 that the center is 0, 0, x minus 0, y minus 0, and then you have a radius of 1. If you square that, it's still 1. Is there any need to write x minus 0? You don't have to write anything minus 0, so that's why they only have x squared plus y squared equals 1. That is the unit circle. So over here it's wanting us to find sine 30 and cosine 30. So we'll look in here at only the part of the circle that we need. And the radius of the circle is 1. That means that this hypotenuse is 1. It's a 30-degree angle, which means this side over here is a short leg, and this side here is a long leg. Also, this is an opposite side, this is an adjacent side, this is a hypotenuse, as well as a radius. So all of that you must be able to construct from scratch. And then you have to fill in the triangle, and we've done a 30, 60, 90 for review on the other page. So if the hypotenuse is 1, we know that the short leg is 1/2, and we know that the long leg is square root of 3 over 2. So you have to be able to find the side lengths. And then from that you'll be finding first sine of 30 degrees. Sine of 30 degrees in this case would be opposite, which is 1/2, over hypotenuse, which is 1. So you just come back with 1/2. And then for the cosine of 30, it's adjacent over hypotenuse, so square root of 3 over 2, and then over the hypotenuse 1. Of course, that's just square root of 3 over 2. Now sine 30, we're not going to write it as 0.5. We're just going to leave it as 1/2. And cosine 30, just square root of 3 over 2. We're not going to make these into decimals. And when you find this stuff, like sine 30 and cosine 30, you have by default found the coordinate. Also made a nasty mark on the screen here. Oh, that'll take everything out, so we'll just leave it. I hate being sloppy, but I can deal with it for now. But we have found the coordinates for point P. Point P has an xy coordinate. And we're going from 0 in the center over to the right, the distance of square root of 3 over 2. And we're going up 1/2. Suppose that P is the point on the unit circle obtained by rotating the initial ray through 45 degrees. Find sine 45 and cosine 45. All right, so here is my initial ray, and I've rotated it like this. And I've written through the problem, but that's no big deal. That is not a triangle drawn to scale, I assure you, but we will pretend that this is 45 degrees. By default, this would be 45 degrees as well. And if we're on the unit circle, then the radius has to be 1. And we know from having solved for this in our review of geometry that if the radius is 1, or the hypotenuse is 1 on a 45, 45, 90 triangle, then you end up with a value of square root of 2 over 2 for each leg. We've already solved that before. And if we're looking for sine and cosine of 45 degrees, then we must also know that this is adjacent, this is opposite, and this is hypotenuse. So that if we come out here to the right and try to find sine of 45 degrees, then we would know that that is equal to opposite, which is square root of 2 over 2, over 1. And of course that just simplifies to square root of 2 over 2. And then for cosine 45 you need the adjacent, which is square root of 2 over 2. And that's going to be over the hypotenuse 1. So it's square root of 2 over 2. So notice that sine 45 and cosine 45 are the same there in the first quadrant. So if you did sine 45 on your calculator, you would get 0.707. And if you did cosine 45, you would get 0.707. They are the exact same. But don't forget that you have point P here. And point P, we have the coordinates of that. From the center, we go over to the right, square root of 2 over 2, and then we go up, square root of 2 over 2. Suppose that P is the point on the unit circle obtained by rotating the initial ray through 60 degrees. Find 60, or sine 60 and cosine 60. I'll zoom in a little higher this time so I don't write over top of stuff. Here's the 60-degree angle. We'll go there. This would have to be 30. Here's your right angle. And don't forget this is point P up here. And if we're dealing with this angle, then this is going to be adjacent, this is going to be opposite, and this will be hypotenuse. Also, don't forget that in a 30, 60, 90, the side opposite of 60 is the long leg, and the side opposite of the 30 is the short leg. The hypotenuse is 1, and we've already solved this 30, 60, 90 triangle for the missing sides with a hypotenuse of 1. Remember, the short leg is half the hypotenuse, so this one is a half. And over here on this side, this will be square root of 3 over 2. We already know that. Whoops. So we'll come off to the right here and find sine of 60 degrees. And that's going to be opposite, which is square root of 3 over 2 over 1. And it just simplifies to square root of 3 over 2. And for cosine 60, you'll have the adjacent, which is 1/2, over the hypotenuse 1, and that simplifies to 1/2. And by default, we have found the coordinates for point P. That means we went from the center of the circle over to the right 1/2, and then up square root of 3 over 2. Suppose that P is the point on the unit circle obtained by rotating the initial ray through 150 degrees. Find sine of 150 and cosine of 150. So here it is, and we're going to go through 150, which is approximately here. So that's 150 degrees. It is point P. But we can't actually do sine of 150 as it is there. We have to draw our leg to go down there and make a right angle. We are essentially not dealing with 150 degrees, although that's what we're finding. But what we're going to be using in our calculations is what degree measurement? 30, because 30 is the difference between 150 and what? 180. Okay, and if that's a 30-degree angle, then this is going to be 60, and this will be your hypotenuse. And I'll zoom in on this stuff since that's all we're dealing with. This is going to be your long leg, and this will be your short leg. You're dealing with this angle, so this is going to be opposite. This will be adjacent. And of course, that's still going to be the hypotenuse. Remember that the radius is 1. And we've already solved for the short leg before, which was 1/2. And the long leg is square root of 3 over 2. Okay, so we have to find sine of 30 degrees. So I'll zoom out a little bit so we can work below. Sine of 30 degrees. Before we do that, we have to remember that we're in the second quadrant. We're dealing with this direction and then this direction. What value, what sign I should say, does y have in the second quadrant? Positive. What value does x have in the second quadrant? Negative. So instead of just square root of 3 over 2, you are going to have a negative square root of 3 over 2. And now we can circle that one and make it official. If you don't remember the signs and the differences around the coordinate plane, then it's going to get rough. So we have sine of 30 degrees equals opposite, which is 1/2 over hypotenuse, so we end up with just 1/2. On your calculator, you can type in sine of 150 and see that it comes back to be 0.5 to verify that. And then for cosine 30, you have adjacent, which is a negative square root of 3 over 2. And that's going to be over 1, which comes out to be negative square root of 3 over 2. If you type in cosine 30 in your calculator, notice that it comes out to be 0.86. That's positive because 30 is in the first quadrant. If you type in cosine 150, look what it comes out to be, negative 0.86. And if you want to, as a test, how about typing negative square root of 3, hitting enter, and then dividing by 2? Look what you come out with, negative 0.866. It's exactly what we just solved for. Don't forget that point P has a coordinate. You are going from 0 to the left, negative square root of 3 over 2, and then up 1/2. These are the quadrants. Quadrant 1. Quadrant 1 has plus plus for its coordinates. Quadrant 2 has negative plus. Quadrant 3 has negative negative, and quadrant 4 has positive negative. That is important to remember. Also, from this, you can generate the sine values for sine and cosine. So, for example, if we were over here and did this, remember I'm going to have an opposite, an adjacent, and a hypotenuse. Now the hypotenuse is always going to be positive. It's just a distance measurement that is diagonal. But what if I did sine? Opposite over hypotenuse, would that be positive or negative? Positive. If I did cosine, which is adjacent over hypotenuse, is that going to be positive or negative? Positive. All right, so let's move over here and just draw another triangle. And this is going to be adjacent, this is opposite, this is hypotenuse. What if I did sine over here, which is opposite over hypotenuse, positive or negative? Positive. What if I did cosine, which is adjacent over hypotenuse? Would that be positive or negative? Negative, right. So let's go down here, make another triangle. We still have the adjacent where it's supposed to be, and this is the opposite and the hypotenuse. If I did sine in the third quadrant, that would be opposite over hypotenuse. What would that turn out to be? Negative. And then I would come out with cosine, which is adjacent over hypotenuse. What's that? Negative. Alright, so over here I'm going to draw a triangle like this. I still have my adjacent. This is opposite and this is hypotenuse. If I did sine of that angle in there in the fourth quadrant, it would be opposite over hypotenuse. What would I get? It would be negative, and then cosine would be adjacent over hypotenuse, positive. So look at what you have. In the first quadrant, sine and cosine are both positive. In the third quadrant, they're both negative. Here in the second quadrant, sine is positive, cosine is negative, but it reverses diagonally to be sine negative and cosine positive. Suppose that P is the point on the unit circle obtained by rotating the initial ray through 120 degrees. Alright, so we will go 120 degrees. Here is 180, here is 90, here is 120, and we'll make the triangle there. And this is point P there. So if I have 120 degrees here, what is this angle in there? 60. Alright, so we know from doing a 30, 60, 90 triangle already that if this is 1 on the hypotenuse, then you're going to come up with square root of 3 over 2 for the long leg and 1/2 for the short leg. So if I had to find sine of 60 degrees, I'm going to have to do opposite over hypotenuse. That would just give me square root of 3 over 2. And if I had to do cosine of 60 degrees, that would be adjacent over hypotenuse. But is this positive or negative 1/2? Negative, right. So it would be a negative 1/2. Don't forget that P has coordinates of back 1/2 and then up square root of 3 over 2. Suppose that P is the point on the unit circle obtained by rotating the initial ray through 240 degrees. Okay, so let's go here and zoom in as far as we can and still keep our place. This is 180. And if I go, and I'm going to shorten this up a little bit, there we go, that's our center. If this is 180 and I'm going to 240, how many degrees past 180 do I have to go? 60, so it's going to have to be out here like this, and we'll go down. This is 60 degrees, this is 30, there's the right angle, and we know the sides of this triangle already. If the radius is 1, the short leg would have to be 1/2, but is it positive or negative? It is negative. And then the long leg is square root of 3 over 2, but is it positive or negative? Negative, right. So if I wanted to find sine of 60 degrees, that would be opposite over hypotenuse, which is a negative square root of 3 over 2. And then for cosine 60 degrees, that's adjacent over hypotenuse, that would be a negative 1/2 over 1, which is just a negative 1/2. And your point P here would have a coordinate of a negative 1/2, negative square root of 3 over 2. There it is. If we were to go all the way around the triangle, or I should say the circle, and do all the increments of degrees, 45, 60, then these are all the points that you would come up with. Remember, we just did 240, and that's what we just came up with there. And we've already looked at 30, 45, 60 as far as those triangles go. We did a 150, we did a 120, and we did all of that by creating triangles in there that we could use using the reference angle. For example, 150, we used 30 because it was 30 degrees from 180.